Dear students, welcome to our new chapter, Probability. Hope all are safe and fine and you are having a wonderful day. Let's see the lesson. Blaise Pascal. Have you seen this scientist or ever heard about Pascal before? This is Pascal, a French mathematician who contributed a lot to applied science, mathematics, and statistics. And many more, even for religious activities, he have contributed a lot. Why Pascal in this lesson? It is because he laid the foundation to the theory of probability. Because long before itself, there were games like gambling and cards and such, and many other games where there are chances involved. In between, while he was dealing with such chances, he came up with the idea of probability and laid the foundation for the theory of probability. Now let us see details about probability. Probability is actually a broad area, but its value is really amazing. It is between 0 and 1. Any value less than 0 or more than 1 will not be a result of probability. Probability can be in terms of 0 or 1 or values in between, which can be represented as decimals or fractions. If it is a decimal, it should start with 0 point until 0.999. The highest value is 1. And in the middle, we have 0.5, which is half. If we have an event which is impossible, that is represented by 0, probability 0. Or if it is sure to happen, then it is represented by 1. Let us see examples. Imagine today is Friday. The chance that tomorrow is Monday is impossible. So the probability that tomorrow is Monday, today being Friday, is 0. At the same time, tomorrow being Saturday, if today is Friday, is certain. So the probability is 1. And also we have values in between with less chance, with equal chance, with more chance, and so on. Let us see an experiment of tossing coin. When you toss a coin and if it landed safely, there are 2 chances only. Either it can be a head or a tail, 2 chances. Such experiments will end up with a result of even chance and the probability will be 0.5. Now let us see more example with a word, leadership. If we write these letters in a card and put them in a box and we randomly choose 1 card at a time, the probability of getting the letter A is 1 out of 10 because there is only 1 letter A, which is from 1 out of 10 it is here, or it can also be represented as 0.1. Let us see another letter, probability of getting E. 1, 2. So it is 2 out of 10 letters, which can also be written as 1 by 5. 2 out of 5 will be here, 2 out of 10 will be here, or we can write it 0.2. And many more. We can say like, what's the probability of getting a letter which is before, let's say, before X? All of these letters are before X in the English alphabetical order. So it is 10 out of 10, which is here, which is a certain value, which is certain. And what is the probability that you will get a Z? Is 0 out of 10, so it is impossible because we don't have 0. These are all few examples of finding probability from a given event. Let us move on to a note. Probability should lie between 0 and 1, including 0 and 1. So 0 less than or equal to any probability in this world less than or equal to 1, which means probability can never be negative or it can't be more than 1. We can actually equate probability in terms of percentage. 0% is compared to probability 0 and 100% is compared to 1. So even chance is considered as 50%. Now let us see question. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. So we have to concentrate here. She did not. She hit 6 times. So how many she did not? 6 times is the number of times she hit. So did not hit is 30 minus 6, which is 24 times. So probability that she did not hit is 30 minus 6, which is 24 out of 30. And don't forget to simplify. Divide by 6, so we will get 4 by 5. Let us see the next question. 1,500 families with 2 children were selected randomly, and the following data were recorded. Number of girls in the family. Out of 2 children, both of them were girls, 475, only one girl, 814, and no girls, 211. Compute the probability of a family chosen at random having 2 girls. So probability of having 2 girls, how many such families have 2 girls? 475. Divided by total number is 1,500. We can simplify by dividing by 5 or dividing by 25. 95 divided by 300. Again divide by 5, it will be 19 divided by 60. Next question, probability of having one girl. 814 divided by the total. So divide by 2. And the last question is no girls. No girls, it is 211 out of 1,500, and we can simplify this. And we are asked to check that when you add all the numbers, are we getting the probability 1? Which means we have to see probability of 2 girls plus probability of 1 girl plus probability of no girls will be 475 plus 814 plus 211 all divided by 1,500, which is 1,500 divided by 1,500. So the probability is 1. Let's see the next question. Refer to example 5, section 14.4 in chapter 14. Find the probability that a student of the class was born in August. So let us see the table. A student born in August. In August, there are 6 students. Probability that a student is born in August is 6 out of, it was given at the top, it is 40 people, or even we can add from the total here. So we can simplify, which is 3 out of 20. Let's see question 4. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. 3 heads, 2 heads, 1 head, and no head. If the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. Means we just have to find what's the probability of having 2 heads. From here, which is 72 out of 200. When we take a large data, this result will be a general data. Anytime when you try this, you will get an approximate equal value, which is equal to 18 out of 50 when you divide by 4, which is 9 out of 25 when you divide by 2. Let's move on. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. Suppose a family is chosen, find the probability that the family chosen is earning 10,000 to 13,000, it is here. Owning exactly 2 vehicles. So here we have to move to the column with 2 vehicles, which is 29. So probability of having 2 vehicles in third group. is 29 out of 2,400, and we can't simplify because 29 is a prime number. Next question, probability of having one vehicle in 1,600 and more. So it is 579 divided by 2,400. Next question, earning less than 7,000 and does not own any vehicle. Less than 7,000 and no vehicles is 10. 10 out of 2,400, which can be simplified as 1 by 240. Number 4, earning 13,000 to 16,000 and having more than 2 vehicles. More than 2 vehicles is 25. More than 2 is 25 by 2,400. We can divide by 25, so 1 by 96. And now the last question is owning not more than one vehicle. Not more than one vehicle means we have to take all these values and all these values. So owning less than 2 vehicle is, here we have 10, 11, 12, 14, and we add all these numbers, so it is 14 plus 2,048, all divided by 2,400, which is equal to 2,062 divided by 2,400. And we divide by 2, we'll get 1,031 divided by 1,200. That's all for today. See you soon.